Hello everyone, welcome back. Today we're going to start topic 2.3, Newton's third law. So before we get started, let's first discuss what are Newton's laws of motion. 2.3, 2.4, and 2.5 in Unit 2, they cover Newton's laws of motion. These laws govern all of classical mechanics. In fact, classical mechanics, which is AP Physics 1, it's also called Newtonian mechanics. So 2.3 will be Newton's third law, 2.4 will be Newton's first law, then 2.5 will be Newton's second law. So it's kind of out of order, but it'll make sense why it's in this order eventually. So let's start with Newton's third law. Newton's third law describes the interactions between objects in terms of the paired forces that they exert on each other. So let's say we have these two objects right here. When they collide, they exert equal and opposite forces on each other. So if you look at the subscripts, the one on the left is the force of object 2 on object 1, and the one on the right is the force of object 1 on object 2. And those are the subscripts there. These forces are equal and opposite, and this equal and opposite behavior doesn't just occur with identical objects. So if we shrink the size of object 2 and shrink its mass, we can see how when they collide, they still exert equal and opposite forces. However, they will still go at different velocities after the collision. Why? Because they have different masses. This is governed by Newton's second law. This is collision and momentum, and you'll learn it later. Don't worry about it too much, of course. So this behavior, we can describe an identity, an equation, kind of to this law of motion. So for every action, there is an equal and opposite reaction. So the force of object 1 on object 2 is equal to the negative of force of object 2 on object 1. The reason why there's a negative is because they are in opposite directions. So let's go over some examples of Newton's third law force pairs. So we can see an object resting on a table. The force of gravity exerts on the object downwards, with the force normal exerting an equal and opposite force upwards, keeping the block in what we call translational equilibrium, where the net force, the sum of all forces, is 0. Now, there's this example with a block on an incline. These aren't equal, nor they are opposite in directions directly. But if we break the force of gravity into components, in the parallel and perpendicular components, like the last subtopic if you want to review, topic 2.2, we see that the force of gravity in the perpendicular direction is equal and opposite to the force normal, which is why in the perpendicular direction there is no net force. Now, this is the tension force acting on two objects over an ideal pulley. This is also an example of an internal force. Internal forces are examples of Newton's third law. Internal forces are interactions between objects within a system and thus cancel out because they act in equal and opposite directions. As a result, they do not contribute to the system's acceleration. So let's say we have the blue block as mass 2 and the green block as mass 1. Let's analyze the forces on these objects. So on mass 1 we have the force of gravity, and on mass 2 we have the force of gravity and the force normal. If we consider the forces acting on the system, the forces from mass 2, the only net force is caused by the force of tension, as the force normal on block 2 and the force of gravity on block 2 cancel out. But the force of tension on block 2 cancels out from the force of tension on block 1, as they are equal and opposite. However, on block 1, there is a force of gravity that does not have any opposing force other than the force of tension, which, as we mentioned earlier, is canceled out. So as a result, the whole system is accelerating in the pulley direction, in this direction, and with a net force that is the same magnitude as the force of gravity of object 1. Now, remember what we said about internal forces? Remember, these forces, they do cancel out. So why aren't they internal? These are not internal forces because they don't interact between objects, different objects. They're on the same object, so they aren't internal forces. But they still are a Newton's third law force pair because they are equal and opposite and do cancel out. Thank you for learning with me today, and I will see you next time.